It'll tell me in a second. You sure you don't play guitar? Hello, everybody. We are live. And we're talking about music. We're talking about furniture. We got a lot of things going on. It's a very active Tuesday. As usual, welcome to the Data on Kubernetes community. It's a pleasure to be with all of you here today. We are doing our 68th live stream session. So we've been doing a lot of things in the last year. As you can see, lots and lots of content. I believe that we got in contact, actually, the two of us several months ago. So it's nice that, something that started such a long time ago is coming to fruition today. The speaker that we have today is a very experienced speaker. You can find lots of talks that he's given on YouTube about a lot of different topics. Today is going to be a special one, certainly going to be a special one. The topic of operators is no stranger in our community. Mixing this, though, with CI/CD and GitOps is a little bit of a new flavor, so excited about that. Have some other questions as well to get into, but we are joined today by, I hope I get this correctly in terms of accents, Adam, and not Adam, correct?
No, just call me Adam.
Okay. So we're joined by this lovely gentleman who's joined us live from Amsterdam. Anyway, very happy to have you with us. Can you just tell us a little about who you are, how you got into this space, and what we're going to be talking about today?
All right. Yeah. Well, thank you very much, Bart, for having me here. So in the past 5 years, I've been working in the cloud-native Kubernetes space as a consultant. I was mostly focusing on the CI/CD and like the how to use Kubernetes aspects and helping clients on that front, which also brought me in contact with operators and building basically more in-house platforms using Kubernetes.
Okay.
And together with my colleagues a few years ago, we started an open source project called the Java Operator Sdk to make it possible for also for Java developers to develop operators easily, same as the Go folks can do. And yeah, otherwise I'm calling in from Amsterdam, and I moved here a few years ago. I love coffee and flight simulators.
It's a good combination.
Yeah, it goes together really well.
I'm sure. Well, yeah, long flights, right? You do have a guitar in the background, but that is not your guitar, or it's just
no, it's my wife's old guitar, which she doesn't play anymore either. Okay. So
but it looks good. It
decoration.
Looks good. It fills out the room nicely. I like that. Okay. Later on, we can maybe take a look at, talk about, I always like to see the comparisons and contrasts between what folks like to do in their free time and more technical things. But when, talking about these operators and thinking about developers, because one of the things that you mentioned is, DX. And so for people that are new out there to this kind of concept is developer experience. Two things. When did you first hear about developer experience? How do you define it?
I had no idea when I first heard about it. It must have been a few years ago. And how would I define it is the same concept as UX, except instead of buttons, being able to find the right button to do the right thing, you need to be able to find the right documentation, have the right APIs that are easy to use, etc. So basically enabling developers to get their jobs done as quickly and efficiently and painlessly as possible.
Okay. All right. So once again, thinking about the pain points, what are the difficulties, the sort of empathy focus that comes into this, and that being with that in mind, I think a lot of this, as much as we say this in almost every live stream, that as much as we're talking about technology, there's always a human side to this. What's the suffering, the difficulties that folks are going through. So with that in mind, because you mentioned previously developers, what are how can you just explain as well too, because we have different kinds of folks in the audience. How do you define an operator? How do developers interact with operators, and what are the problems that they frequently encounter?
Right. You mentioned pain points and DX. Let me rather start with what the general problem that I've seen in many companies I've worked with before we jump into why operators is basically developers getting their hands on some resource, which is the bigger the company or the more security and process conscious they are, it gets harder and harder, right? So I've seen developers using the same database for 3 different purposes, because they know that if they want to request a new one, that's going to take a few months, so they rather just don't go there. So I'm thinking in this kind of enterprise environment where provisioning databases is a very controlled process, very manual process. You have to send emails and requests and have to know the right people to get it done faster. And here come operators which provide a paradigm that can help with building out platforms that allow for more self-service to developers. So a big part of UX and the empathy with people is getting out of their way to be able to do their jobs, and that means self-service. But self-service doesn't just come for free. You actually have to do a lot of things to make it work. So what operators are, it's actually a really simple concept. So because there are so many things you can do with operators, people often get like a bit lost in the whole topic is really complex, and there are all kinds of nuances. But in the end, the whole thing is all about Kubernetes allowing you to store any kind of like custom resource in the Kubernetes API server. So you can, the basic stuff you create are deployments, pods to run your containers and so on, and services to expose them to the outside world, and these kind of objects. However, Kubernetes lets you define any kind of object in the API server. Basically, it's your database schema. The custom resource definition is your database schema, and then you can create instances of that, or like as if they were kind of like documents. Yeah, it's basically a document database. You can create documents that adhere to that schema. So let's say, and here comes the part with like solving this self-service provisioning problem. You can define, let's say, a resource of type database, and then allow developers to create instances of databases which will have the exact properties that you allow developers to define. So let's say they'll probably not be able to define all the permissions and everything, because that will come from like an internal business logic, but they will be able to name the database. They will be able to define the character encoding and what other any kind of parameter you can come up with. They store this as custom resources in the Kubernetes API server, and then you, as let's say the DevOps or database admin team, can build an operator that encodes your organization's logic to actually providing that database to those developers. So with this, the developers get a nice familiar API, because by this time they are very familiar to work with the Kubernetes API server. You can just do kubectl, create my resource, and then this operator in the background will be able to act on the information in that resource and provision the actual database. And that database doesn't need to be something that runs on Kubernetes. It might be your old Oracle database cluster, but this operator will have admin access to that cluster, can create a new database inside it, and then communicate the credentials back to the developer through the custom resources in the Kubernetes API server. So in the end, this whole custom resource operator thing is more of a pattern, rather a design pattern, than an actual technology, because Kubernetes in the end doesn't know that operators exist. Operators is just another thing running on the Kubernetes cluster that happens to talk to the Kubernetes API server to like read all the resources it's interested in. That was as short a description as I could manage.
As you said, it's simple. It's really simple when it comes down to it. No, but perhaps maybe it's not as overwhelming as folks might see it as being. It does seem, and once again, in our community, a big thing has been these conversations about how can I get my data on Kubernetes, stateful workloads, things of that nature. And operators do seem to be playing a very important role here.
Yes. Let me bring some clarity to that. So, because what I've just described here is a very different use case to operators than what folks mostly use operators for. So when you want to run some kind of database on Kubernetes and you use an operator for that, in that case, the operator is more of a tool for the DevOps team to make sure that database runs correctly on Kubernetes. So in that case, the operator is not really managing the databases that the developers would use, like the database, like in Mysql, let's say you call it a schema, right? So it's not managing the schemas, but it's managing the actual running database processes to make sure that it's all clustered correctly and it's backed up and all these things. So in this case, and the custom resources that you use to control that operator will be something like I know a Kafka instance, and then it actually spins up, or a Kafka cluster, or a whatever database, or like a MySQL cluster. While that's a different use case to allowing developers self-service through just provisioning database schemas, right? Maybe you want to allow developers to spin up databases for themselves, although that's, I think, in production scenarios, not very likely, unless we are talking about like 100-person developer team developing something massive that they just take care of all their stuff.
Yeah, okay. One other thing to touch on, because you mentioned custom resource a couple of times. It was mentioned by another one of our community members, Alvaro Hernandez, who is a fantastic communicator. Shout out to Alvaro, that he tweeted about 2 weeks ago that custom resource definition is his absolute favorite feature on Kubernetes. Why do you think that would be the case? Do you agree? And if not, what's your favorite feature?
I would still stick to the fact that you can just run things really easily. So I still like deployments. But yes, custom resource definitions are awesome because it's a very simple feature. It just turns the Kubernetes into a document database. And why that works really well, it's not better than any other document database, really. Why it works really well is that you're already using Kubernetes. So let's say this whole operator thing, if you are not using Kubernetes, it's worthless for you. Don't go and install Kubernetes because you want to run some operator, because you want to use some custom resources. They are just mindless data structures, right? You will not be helped at all by in that case. However, if Kubernetes is already your target platform for deploying stuff, then suddenly you have the same exact CI/CD pipeline, same tooling, same everything to store other kinds of resources that are related to your infrastructure, right? So yes, maybe one resource is describing Docker containers to be run and ports to be exposed, but from a developer team perspective, your database instance is also one of the resources that you will want to define for your environment. And it will sit really nicely next to all those other Kubernetes resources in like nice collection of your YAML files that you then put into Git. You run a CI/CD pipeline that then applies them to Kubernetes, and then an operator can kick in and actually make sure that the database happens.
Okay, good. But so you still favor deployments? That's okay. Everybody. Not everyone's going to agree on the same thing, and once again, depending on experiences. And speaking of experiences, in your learning process, now you're working at Styra, but what were the things that worked the best for you? Because once again, talking about empathy and pain points and things like that, what have been some of the pain points that you've experienced along that, and how have you been able to get over them?
Can you be a bit more specific on like what are we talking about, like operators in general?
Yeah. Like I said, with the realization of also the self-service things, like how did you get to that point? What were the steps that you had to go through in order to get there?
Yeah. Okay. Right. So the most interesting experience I had with applying operators was building an like kind of enterprise grade CI/CD system where a developer team could ask for their own CI/CD pipeline that would take their code from development all the way to production in a really controlled, compliance conscious environment. And in this case, so what the steps we went through was, first we just implemented this CI/CD pipeline in the like naive way how you would do it in a small company. Just create a Jenkins file, extract some functions, etc. Make sure that it works for one team. Now, a small company at this point would just go and copy paste the Jenkins file and just reuse it for other teams. Everybody would kind of customize it to their own needs and whatever. But once you, in this environment, we had to deal with like hundreds of teams. So that meant we had to fully automate the creation of it, because it's never just a Jenkins file, right? It's namespaces on different Kubernetes clusters. You need to have the credentials to those, and etc. So the next step was we created a command line application that could do the provisioning of all this, all the Jenkinses, the pipelines, the namespaces, actually even the Git repos, because there was multiple Git repos and all that. So, and once we had that command line tool, you have to run that from under some credentials on somebody's machine. So we still had to get an email from a development team to run the command line thing to provision something for them. And even provisioning was pretty automated and fast. We were still soon way overwhelmed with requests, and suddenly there were the new requests coming in to also change something that has already been created before. And that's when we started thinking about full self-service automation. And we were thinking of like, okay, so we expose maybe an API. How do we give this self-service functionality to the developers? And we realized that we're already running on Kubernetes. So why don't we just give developers the option to like create objects in the Kubernetes API server? And we actually gave them the object called team that they could create, and then a whole bunch of operators would kick in the background, reacting to this team object and start going around the infrastructure and creating Git repos and Jenkinses and all the things that needed to be created for a team. So that was the journey to like full self-service. And in the end, we had to add an API server anyway in front of the whole thing, because it turned out that just Kubernetes RBAC wasn't enough, because we had to have rules like the developer who created something can delete it, not anybody but that particular person, and like do some audit thing and whatever that we couldn't get done with Kubernetes. So that was a really complicated thing. But that got me really deep into operators, and we constantly were, because this was a new Kubernetes project, we were constantly also asked all kinds of questions about like exactly like the database provisioning.
Yeah.
So they had their I think it was Microsoft SQL like server farm basically. And now should they run? Do they need to run all that on Kubernetes now, or like what to do now with the database servers? And what we kept telling them was that no, you should not run that on Kubernetes. There is no good reason for you to do so. If you're happy with how your database cluster works, what you need to do is to really embrace the cloud native mindset, is to just expose that MySQL cluster to your developers in a way that is fast, automated, and easy to consume for developers. So while we never actually did this, but we really advocated to like creating maybe their own in-house operator that would reach out to the Microsoft SQL server, create a database, and then store the credentials in a secret for the developers to consume in their namespace on the cluster.
Okay, wow. So once again, I think that the importance here is practical hands-on experience. In your case, it was a particular project you were working on, starting out with Kubernetes, getting into the weeds, getting your hands dirty. And speaking of which, we got a comment on YouTube. We got a couple of comments. One that question that I'm going to save for the end, which is related to decoration in your house, which I don't think is terribly relevant now, so we'll get to it later. The second question, though, is that someone's asking, would it be possible for you to show us maybe how things look, under the hood?
Yep.
If you want to share your screen and we can take a look.
Absolutely.
Yeah.
Yes.
And just a reminder to all the folks on YouTube, thanks for the questions. Try to be as specific as possible. If there's anything in particular that you want to see, I'm sure that way it'll be easier to have things a little bit more focused. Always remember as well, you can check us out on Twitter. You can check us out on LinkedIn. We have a speaker who's very available for questions and very knowledgeable. So yeah, so let's jump in and take a look.
All right. So what I have here is a MySQL operator written in the Java Operator Sdk, which right now we will not go into Java. Basically, this could be written in whatever. The important stuff here that we need to look at. I have a MySQL server running on my Kubernetes cluster, but that's just a complete implementation detail that MySQL server could be running anywhere. Important is we will be using a single MySQL server. What we want to expose now is creating schemas in that MySQL server, not creating the MySQL server itself. So I'm closing this one and oh, is this visible, by the way? Should I try to increase the, maybe I'll increase the font size.
Yeah, if you can. Let's see. If you're having difficulty seeing this, please just let us know in the YouTube chat and we'll adjust things accordingly.
No, I'll definitely, because
Yeah,
I know that also some compression likes to happen.
a little bit of zoom always goes a long way.
Yeah, totally. I think I'll add a little bit more. Let's make it 20. Is that good?
It looks great to me. Folks out there, can you see? Can you see? Let's see. Any feedback? Seems to be okay. So yeah, go for it.
All right. So the most important stuff, I'll not be really showing Java code today. I'll rather be showing the schema. That's it. So this is our custom resource. This is the basically the API we give to the developers.
Sorry, if you can you zoom just a little bit more?
Absolutely.
Yeah, thank you.
Let's make it 26, even 30. Yeah, the left side I can't zoom in, but I think that should be okay. Or there is this this presentation mode that that IntelliJ has, but now that made everything full screen, which on my gigantic screen is kind of probably looking worse. So let's just not do that. Oh, look, everything became bigger on the left side too now. All right. So here we have, this is a standard, like a Kubernetes custom resource. You can see it's mysql.sample, the Java Operator Sdk /v1. That's my type, or the short version MySQL schema. It has a name and it has an encoding. That's it. I didn't go further to specify more parameters because I couldn't even really come up with anything. I don't know if I mentioned that I'm not really a database expert. So, but that said, you can imagine having a whole bunch of other things here. Now, this is the custom resource definition, slightly out of date. I think I should I'll need to update this here, the version, but never mind that. So this is basically our schema defining our MySQL schema custom resource. So you can see that there is all kinds of boilerplate here. We define the plural name, we define the singular name, we define the kind, and then we have an open API v3 schema defining that the only required property is encoding and nothing else. So this is a really simple custom resource, but this is how a custom resource definition looks like. So what we do is we go to, do you see my console now?
Yep.
Okay, I'll make that one even larger too. Just a sec. Yeah, let's make that 30. Yep, okay. So what I'll do now is how I add this custom resource to the Kubernetes cluster. Type kubectl apply crd.yaml. This is the custom resource. It's been already applied, but I'm just gonna show it again. Yes, well, it just says it's unchanged. But what this does now that we have our custom resource definition applied to the cluster is that I can ask Kubernetes stuff about this. So I can ask kubectl get schema. You can see that now Kubernetes understands what schema means. Maybe it would have been nicer to name it MySQL schema, but anyways, we mean the MySQL schema by this now, right? So I can I can list the MySQL schemas, and I can create one. Here is my sample schema. It's named MyDB. The MySQL server that I'm running is actually exposed to my computer. This is all running on a remote Kubernetes cluster, but I just port forwarded it to my computer. My workbench is connected to that, and I can't make that bigger, but all we need here is just like, we can see that on the left side, there is a list of 0 schemas. This MySQL server is completely empty. And I'm going to now create a new MySQL database by creating a Kubernetes custom resource. And for that, first, I have to run my MySQL operator. Oh, it's already running. Okay, I'm way ahead of myself. All right, so that should just be then kubectl apply f in the Kubernetes directory. What was the name of the file? Schema.yaml. Yes, so now MyDB has been created. So that means that in the Kubernetes API server now there is a, oh yeah, when I type K, that's just alias for kubectl. Kget schemas, and here we go, we can see our MyDB schema. This doesn't mean that the actual database has already been created. This just means we created a custom resource in Kubernetes. We need our operator to now pick this up and create the actual schema in the MySQL server, which might or might not have happened. Let's see. Let's just go to MySQL workbench, say a little prayer, and it's not there. So that means that the operator probably had some trouble doing this, and I need to exit the presentation mode because I can't find the console. Otherwise, yes, we have a nice juicy exception here. No resource type found for MySQL schema. Okay, the demo gods are not particularly kind to me today. What the hell? I've wished at least for a, oh, it says unauthorized. That's strange. Let me try to just restart this.
No worries.
That might help. So now that I restart the operator, it will not expect any like action from me. Yep, we're getting the same problem. Because the operator just notices immediately that a MySQL schema object has already been created in the Kubernetes API server. So that's something I'll explain now why this is a really good thing. So the operator pattern makes everything really resilient because the operator doesn't rely on the operator running at the moment you, as the user, create the custom resource object. It's not like calling a synchronous API. It's a very asynchronous, robust system where the operator might or might not be running at the moment you create the custom resource, but once it starts up, it starts reconciling the real world to what you defined in the API server. And normally it would do that, except when it just fails to do so. That also means that, let's say I would just delete this database, the operator would go and recreate it because its job is to constantly make the real world look like the definition, same like Kubernetes does with your deployments and pods. So JSON mapping exception. Okay, it expects. Oh, why? Schema X. Okay, I think the problem is that the schema object does not have, oh, right. Yes, sorry. I was part of a little hackathon, I think, where people have actually changed this code. So I just need to switch to the official version of the code. Let me just do that real quick. I need to grab this from, maybe shoot me another question in the meanwhile while I'm messing around with this.
Oh, we can do the off-topic question. So the off-topic question that was asked quite early on, let's see, by someone in our YouTube chat, was regarding the decoration in the background. Let's see, let me get to my questions. And is that a pole dance bar behind you?
Oh yes,
very
it is indeed. That's my wife's hobby.
Good for her. The thing is, I would totally do it. I would just be worried that I'd hurt myself.
Yeah, it's I tried and it's really difficult.
Yeah.
Like not the sexy kind of pole dancing, but the one where you like pull yourself up.
No,
and your legs are above your head, and like it's more like the pole fit. It's called pole fitness.
Yeah.
And it's like, yeah, it's really difficult.
No, it seems really difficult, and you have a hardwood floor, so it's not a very forgiving surface if you fall.
Yeah, well, honestly, in those poses, I guess if you fall, like it's okay, it doesn't matter anymore.
Yeah. Yeah, just kind of straight to the hospital at that point. But yeah, no, I think it's like I said, I don't think anyone would say it's, it looks really easy, but it certainly doesn't. We got a comment right here. It seems you used schema in one place and MySQL schema in another. Someone mentioned that.
Yeah, if we look at the custom resource definition, we can see that this is the official name of the custom resource. It's schemas.mysql.sample.java Operator Sdk. And then in Kubernetes, everything has a kind, and that's the thing that you actually reference in your custom resource here. And that I called MySQL schema, but this stuff I just call schemas and schema, but it's completely up to me, and I should have named this more consistently.
Okay, duly noted.
Yep. So, all right, how to set a git remote. Yes, git remote set URL. I guess we just dash add. Okay. Origin null, because we already have origin. And there what the hell happened here? Come on. Okay, I have a bad feeling about like maybe the terminal is not working in oh man, I'm sorry about this.
That's okay.
Git remote set URL dash add original. Yes, that one. No such remote. Oh man, would help if I knew how to use Git. Oh yeah, it's just git remote add.
All right.
And name URL. And now it will be interesting to see if I can pull from that. Okay. I'm not sure if I can just do this because the branch on the command line. Main. Okay. Let's see that. No, the schema class is still empty without any. Oh no, sorry. Yes, we have schema spec, schema status. Anyway, so it might be that I won't be able to solve this now. If it's if the new code, everything looks still the same, then I don't know what's the problem here. Yeah, it's still no resource type found for. Yep, I'm really sorry, but I think it's best if I don't try to solve. What was supposed to happen was that the operator would be running, and it would go to this MySQL server and create a new schema here. And once we would go and delete the schema object that we created, which is the schema mydb, then the operator would go and delete the schema from MySQL. So basically, and what's really interesting to see here is that this schema doesn't contain like any access credentials or anything to the database itself, right? So you have a complete separation of concerns to what do you expose to developers through this custom resource versus what's all your company's business logic basically on who is allowed to create a database. Can people change the encoding? Whatever, you can decide and encode this logic in the code of the controller. So by the way, the controller looks like this. You can see here is the SQL statement to create the schema. So even though developers don't have direct access to this MySQL server, the operator itself does. So the operator itself has admin rights to the MySQL server. It also creates a user for that database, grants the privileges, and what it would do, which is a shame we can't see that now, but what it would do is, yeah, by the way, what we're working on right now on the as part of the Java Operator Sdk is to have tests for our samples because they break sometimes. It creates a secret in the namespace from where the custom resource was created. So inside that secret, it places the credentials to this new user that it created. So it doesn't just dumbly create a new schema in the MySQL server. It will also communicate back to the user what the credentials are by creating a secret object in the namespace. So then a developer can actually use that secret, the data from that secret object, the username, the password, and the JDBC URL to make a connection to the database, but only to that one schema and not use any kind of admin connection. So there is always a new user created for every single database instance, and it's all fully self-service. Right. So there, that's I think where the demo ends. Are there any questions?
No, we will get plenty of questions, I'm sure. Just a follow-up thing about the schema versus MySQL schema. Another point mentioned by Robin Hood is the name of the person. Your very first item shown on the blue screen seemed to be schema, not MySQL schema. Is this why it's saying MySQL schema is not existing?
So basically how this mapping works. I mean, something's definitely wrong here, but so the mapping works by this group has to match what's in the CRD, this version has to match what's in the CRD, and it's true we are not specifying the exact name and the CRD, and yeah, actually that might be the case, that because this is just schema and not MySQL schema. But, let's try to do this because yeah, I don't know how it would match this schema to the MySQL schema kind. So maybe we can either define kind here. Let's just try this.
Okay.
All right, we have a different error now. CRD was not found on the cluster. Aha. So it is generating the name of this. So it did manage to match this to the CRD, because now it's trying to match MySQL schemas.mysql.sample. So no, the kind was not the problem, because it clearly could find the CRD, but somehow it still couldn't. Then when it was doing the deserialization of the data, it still couldn't, which is like really weird. Then like I have no idea why. How can it be that it does find the because when the operator starts up, it doesn't really need the CRD, but it checks if it's there. So it clearly can find. It says it registered it for CRD, the schema class for that custom resource definition. So it can do that, but once we add the actual schema, it cannot deserialize it because it doesn't know what class to use. Yeah. So yeah, no, I was hopeful for a moment there, but it was all in vain, unfortunately.
That's all good. It's all good. No worries there. I guess, other. One of the things that was kind of mentioned there too is the topic of GitOps. It's a word that we're hearing a lot. It's definitely a buzzword. I think there was a co-located event in KubeCon that's just going to be focused on that. What would you recommend for folks that are wanting to get started out with GitOps? What are some of the best ways? Obviously, practical experience counts a lot, but what are some of the resources or recommendations that you would have for people that are getting started with that?
Okay. Right. Well, there is obviously a lot of information out there if you just Google it, but what would be the best way? So first of all, you need to understand your goals with this. So there are basically two GitOpses, I would say. That's really important to understand, that GitOps for application deployments versus GitOps for infrastructure management is going to be somewhat different. So any kind of tool that does automatic reconciliation, you can use GitOps on, which is basically Kubernetes or Terraform, or the other like Terraform equivalents like CloudFormation, right? And when you manage like rarely changing but very expensive resources, like you usually do with Terraform, or maybe with Kubernetes because you're running your database on Kubernetes, there your whole testing pipeline and everything will be different than when you're managing like frequent application deployments, where it's usually the code inside the same container that changes, and replacing and deleting it and rolling it back is like really cheap, right? So that's the first thing you need to start thinking about, is like, am I deploying applications using GitOps, or am I managing my infrastructure using GitOps? And to be honest, managing infrastructure with GitOps is something we have done for ages. We just didn't really call it GitOps.
That's the other thing, which is a classic thing that happens, I think, with almost every technology, right? It's like we've generally been doing something, we kind of group things together. There's a little twist and put another name on it. And it seems like GitOps fits into that too, right?
Yeah, exactly. It's I think what really makes GitOps specific to other, like compared to like more general infrastructure as code practices, is that you would, after code merge, you always do a reconciliation. So no more manual steps, no more like check and approve and whatever inside some kind of pipeline after you merge to Git. So everything has to happen before you merge to Git. I mean, you can have testing and everything, but you would like test the PR, and after it's merged to Git, there has to be a fully automated process. And you can see that, for example, Terraform doesn't lend itself really well to that. It expects that you will do a planning step, then you will read the output of the plan, then you will think about it a bit, go have a coffee, come back, push a button in Jenkins maybe, or even just do this locally. So it's kind of, the default is that kind of process. So you would be, it's not entirely intuitive, and many people don't use Terraform in like this GitOps way where you merge and then it's done and it's just an automated process happening from there.
Yeah.
On the other hand, with Kubernetes, this comes more naturally also because it's used for cheap application deployments where rollbacks are possible and so on. So there it's more often used in this way, where once you merge to Git, and also there are like tools that explicitly like do this thing where like Argo CD or Flux CD, which the whole purpose is that they are looking at your Git repo and they do a reconciliation immediately as it changes. There is no pipeline, no like steps and phases and whatever. It's like it's immediately reconciled to your Kubernetes cluster. And then Kubernetes starts reconciling all the things to your like resources that were inserted into the API server. So yeah, there are these two different worlds, and especially I think, well, GitOps really emerged in like the application deployment world, but it's very valid in both. So yeah.
Okay. Just a follow-up question from previously. What were you defining on the blue screen?
What was I? Sorry, say again.
Yeah, the question is it says what were you defining on the blue screen? With the blue screen where there's a schema and not MySQL schema?
I'm not sure I'm getting the question, but let me share my screen again.
Yeah, I'll ask.
The blue screen. Well, the blue part of the screen was the console.
Yep.
You mean here?
Yeah. Let's see. Waiting for a response.
So the question is, what was I doing on the console?
Yeah, defining. Yeah, on the blue screen. Yeah.
So what I was doing here, like, sorry about like, I was assuming familiarity with kubectl, but basically what I was doing here is using the Kubernetes client tool, which is called kubectl, and using that to insert documents basically into this Kubernetes API server / document database. So basically creating custom resources in the Kubernetes API server. So this schema YAML file is this file that we were looking at. So this defines a MySQL schema, and then I used kubectl apply to insert it into the API server.
Okay, what was said now is, did you create an object on the blue console?
Yeah.
Okay.
Yeah. So this kubectl apply actually creates the object inside the API server. So that's why I can now do kubectl get schema and get back the MyDB object. If I would say kubectl get schema output as YAML, then I would get not the exact YAML I created, because Kubernetes has a whole bunch of metadata to it, but all the things that were in the original YAML are still there.
Okay. Very, very good. All right. Now, okay. Did you create an object? Okay. So in the schema YAML, did you define a schema or a MySQL schema?
In the schema YAML, I defined a MySQL schema. So it's an input for the operator that then talks to the MySQL server and creates the actual MySQL schema.
All right, very, very good.
So it would create a MySQL schema inside MySQL with the name MyDB and with the encoding UTF-8.
Okay, all right, good. Now getting to the home stretch. All right, if you have questions, you can keep asking, but we got a couple of specific things that I mentioned that I wanted to get to, just because I knew you had talked about this, previously when having a customer that had everything with certain Microsoft databases and whether or not it was a good idea to put them on Kubernetes. This is a big question for our community, all right? This whole debate, when does it make sense? The use case, is it necessary? Is it beneficial? Not just the what and the how to work with data on Kubernetes, but also the why. So do you think Kubernetes is ready to handle stateful workloads in production? And why or why not? Yes or no? What makes it possible? What's making it difficult? What do you think?
Right, okay. First of all, let me say this is going to be a pretty uninformed opinion.
Fine.
I'm not the expert on this topic. in my opinion, it does make sense to run databases on Kubernetes. Well, the biggest problem here is, of course, like moving the data around, right? So how does the clustering work? What kind of storage do you have under the database? You could theoretically just have like local storage and then rely on replication, moving the data around, or you're sharing some kind of network storage under the database, and then it's up to the network storage to make sure the data is always persisted and so on. And these are the things I can't really speak to. And I don't know if Kubernetes makes anything worse, actually. So that's the first thing, right? Like when you run databases on virtual machines, Kubernetes runs everything on virtual machines also. Maybe you by default have less control on what runs on which virtual machine, but even that you can actually get full control if you want to. So that part pretty much works the same in the end. The only thing is that you're not really using Kubernetes as you're kind of supposed to, or whatever. But
and that can be debated, the initial design as opposed to how it's evolved and the capabilities that it has today.
Yeah. In the end, it's just a scheduler that puts processes on VMs, and there might be things I'm forgetting about here. No, that might be. But on the other hand, what Kubernetes does give you is a full management interface and then like a automation platform that, yes, it can run processes on VMs in a really, really nice way. It can restart them. It can make sure that a VM dies, then it can move the process, etc. So you get all this stuff. If you add to that like a really intelligent, high quality operator, if one has been written by somebody for your database, then it can be a really powerful platform. So I would totally recommend running databases on Kubernetes, as far as you don't run into like, I don't know, performance problems that you have like maybe more options to solve on a VM that I could imagine. Yeah. You have more access to the whole stack with Kubernetes only exposing the hard drive in certain ways through like limited APIs, because of course that's on purpose. But maybe on a if you have the direct access to the VM, then you have more optimization options. So that's where definitely you might, that's the usual case of more abstraction versus more access to the deeper layers of your stack.
Good. And just as a follow-up to that really quickly, do you think the biggest issue about running data on Kubernetes is the technology or the lack of trust or knowledge that people have?
Yeah, I don't know, like I'm pretty sure there is lack of trust, and I'm pretty sure there is both, but no, let me just not answer that question because I'm getting out of my depth.
You don't have to. No, you don't have to. No, we're not gonna quote you on this. That's okay. Following up, we got another question. We got still following the stream of questions in the YouTube chat. I'm thinking the fact that going back to the why can't you? Okay, so going back to the schema or MySQL schema. Here, why can't you do k get MySQL schema? I'm thinking the fact that you can't do k get MySQL schema relates to why the error message is that a MySQL schema resource doesn't exist. Like you created a schema resource type, not a MySQL schema resource type at some step in the process.
Right. No, that's not the case, because if we look at not the custom resource definition, you can see that the custom resource definition links the schema name to the MySQL schema name. So these are both names of that same thing. Just one is the name that is used on the command line using kubectl. Those are these names, and then there is the kind that is used in the resource definition. And these should all be mapped correctly to, and the name of the Java class does not matter, or it does, but this is generated from the name of the Java class. So this is how it links the two, but or I think no, through this one. So from the Java class, name will be lowercase and pluralized And that's how we generate this. Or you could define it exactly yourself in the using the annotations to map the Java class to this. You don't have to rely on this kind of naming convention thing. But we know that this part of the process of matching the CRD to the Java class has actually worked. So because otherwise the operator fails to start up. So there is some other problem, and I'll share it on Slack once I figure it out.
Good. No, that's a perfect excuse to continue the conversation. And speaking of which, we have some questions from our stellar interns that we're not going to have enough time to get to. So we'll also carry the conversation there. We'll just keep going on Slack. Before we finish, though, we have a tradition in our community that we're very proud of. Where while you are giving your talk, we have an amazing artist who behind the scenes is creating an artistic depiction of what you were talking about. So I think you can see my screen. So our artist is Annika, and he always does an amazing job of being able to do a sort of synthesis of all the different concepts that were covered. Obviously, there were a lot of things that were covered. But anyway, I think it's a nice touch. So we'll be sharing that on with you. For folks, Adam's really easy to find in Twitter. His name is Adam Sandor, but the O is 0. So quite easy to find there. Got lots of talks on YouTube. I think this was really good. We got some great feedback in the chat as well too. People like to see the debugging process. So that's what we got to see here too, is that, when, things aren't going to go exactly as planned all the time. As you mentioned, the demo gods have their different days. So yeah, I think we would definitely like to have you on another meetup in the future. Very, very informative, very honest. I really appreciate that. So anything else that we need to know before we finish?
Yes, I just looking at the logo, I just realized that I actually have a Data on Kubernetes Meetup t-shirt that has arrived like a month ago, and I forgot about it.
That's okay. I didn't want to get too pushy on the corporate branding, so I prefer if you want to wear it, you wear it. If not, it's not the end of the world.
The only reason I'm not wearing it because it arrived like so early that I already forgot I had it. But yes,
because we've been
thank you very much for the t-shirt.
No worries, man.
Nice
we've been talking about this for about 6 months. So anyway,
yeah.
you can wear the t-shirt whenever you want in Amsterdam and tweet it, whatever you want. That's fine. Thank you very much for all your time today, and hopefully be talking to you soon. And like I said, for all the folks out there, thanks for all the questions. We'll continue the conversation in Slack. Another announcement: we are doing a co-located event in KubeCon. So if you would like to give a talk, we will be, or if anybody would like to give a talk, we'll be sharing the. I'll share the CFP here in the chat. But yeah, the CFP starts from now. We'll be going all the way through August till September 1st. We're looking for talks that are end user focused. Please, no vendor pitches. I can say that 100 times, and we'll still probably get some vendor pitches. But anyway, got another nice comment from Peter here, lastly in the chat, saying many thanks. You should write a blog post on this. That being said, if anybody's interested in doing blogs, we now have someone in the community who's just focused on this. So this is the perfect excuse to continue the conversation there as well. Thank you very much. Have a wonderful day, and we'll be in touch. Thanks, everyone. Take care.
Thanks. Bye-bye.
Bye-bye.